Hello everyone, my name is Reza Rafi. I'm a lecturer at FinTech. I'm going to provide a tutorial on the second assignment of my Big Data and Analytics course. This assignment is about using a MapReduce paradigm to cluster data. We use k-means clustering algorithm to cluster users in the Movielens dataset. The Movielens dataset can be obtained through this link. This is the link of the dataset. As you see, there is a zip file. You need to download the zip file and extract the file. In the dataset, you will find a file called ratings.csv. We will work on this because it contains the users and the users' ratings to the movies. As you see, this is a CSV file having 3 columns: user ID, movie ID, and rating. Rating is a number, from 1 to 5. So, for example, user 1 has given the rate 3.5 to movie 2 and the rate 3.5 to movie 20, etc. Right? So we want to find the similarity of the users based on the ratings and cluster the users on these ratings. Let's talk about the clustering algorithm first. If you remember in lecture 7, I covered this topic. This is the k-means clustering algorithm. As you see, this algorithm needs a set of centroids. So we need to consider, for example, several users in the dataset as centroids. These users would be cluster heads. So we will compare the other users and see um, each user is more similar to which centroid. Of course, instead of the similarity function, we use the opposite function, which is the distance. So we find the centroid which is the closest to each user, and that centroid determines the cluster of that user. Okay, so this is the algorithm. We can randomly generate several centroids in the Movielens dataset, and then provide a distance function and calculate the distance of each user to the centroid. And later, we will evaluate our clustering algorithm using this SSE metric. This is the abbreviation of sum of squared error. So SSE stands for sum of squared error and comes from this formula. So for each cluster, I need to find the distance of the cluster members and the centroid and square that distance and sum up all of these distances, the square of distances, and this will give me an indication of how much that cluster is good. The cluster with lower SSE would be better. Okay, before starting implementation, let me explain a little bit about the theory side of this. I assume that I have 5 movies, and this is the list of ratings for one user. The user has rated 3 movies, so probably the user is very interested in this movie because the higher rate means more interested the user, and the user is not very interested in this movie. But we don't know about movies 2 and 3 because the user has not rated those movies. Now assume that I have 2 centroids, so I want to cluster the users into 2 groups. The first group has this centroid and the second group has this one, and you see that these centroids are users themselves, and they have rated some movies. So these are the movies rated by the first centroid, and these are the movies rated by the second centroid. Now I want to know which centroid is more similar to my user. Uh, in other words, which centroid is closer to the user. Um, if I want to use the Manhattan distance function for calculating the distance of the user to the centroid, it's very easy. I need to find the movies rated by both the user and the centroid. So for example, for centroid number 1, the common movies rated are movie number 1 and movie number 4. The, the Manhattan distance is just the absolute of difference between ratings. So for example, the difference between ratings for movie 1 is 2. You see that this comes in the formula as this. And the distance of rating for movie 4 is 0 because both the user and the centroid have rated this movie the same. So the Manhattan distance of user 1 and centroid 1 equals to 2 because of the difference of rating for movie 1 plus 0, no difference in the rating for movie 4. This is totally equal to 2. For centroid 2, the distance of the user comes from this formula. As you see, they both rated movies 4 and 5. The rate of the user for movie 4 is 1 and the centroid is 3, so the difference is 2. And the same for movie 5, the difference is also 2. So the total difference is 4. So the Manhattan distance for user 1 and centroid 1 is 2, and for user 1 and centroid 2 is 4. So user 1 is closer to the first centroid. So user 1 belongs to the first cluster. Another function you can use to determine the distance of the user and the centroids is Euclidean distance. Um, this finds the square root of the square of differences between ratings. So these are the difference between ratings. You see that it is squared, and the total sum is we find the square root of the total sum. So the distance between user 1 and centroid 1 based on this formula is such, and for um, user 1 and centroid 2, the distance is a little bit uh, longer. So again, if I use this function Euclidean distance, again, I will conclude that user 1 belongs to cluster 1. All right, if I want to evaluate, for example, cluster 1, I assume that these are the users belong to cluster 1, and these are the total distance for each user to the centroid of cluster 1. So, for example, if you see here, the first user distance to centroid 1 was 2, so I mentioned 2 here, and I haven't mentioned users 2 and 3 information, but assume that user 2's distance to its centroid is 5, and for user 3 the distance is 3. So SSE comes from this formula. I need to square all of these individually and sum up. The sum of this will give me an indication of the quality of the cluster. As I said, the lower this number, the better that cluster. Okay. Now we need to find several centroids among the users. As I said, the users rating you can find in this file, ratings.csv. You can either randomly choose centroids, or you can choose it systematically. So for example, I will choose, in the next step, we need to choose centroids. You can do it either randomly or systematically. For simplicity, I choose 2 centroids for 2 clusters. If you need more clusters, you need to choose more centroids. I need for example, the last 2 users as centroids. So the last user ID is 7120 and the user before that is 7119. So I choose these two users, so I have to select these two users with all the ratings, cut and paste it in a new file for Centroids. Okay, I paste those two users information here in a file named centroids.csv, for example. So this file includes the information of those two users as centroids. So I will copy and paste the header of the previous file, I mean the ratings.csv here, to let this file has the same heading. Okay, here it is. Now you see that I have a file named centroids.csv with the same structure but with only two users. This user ID 7119 and 7120. So these are going to be our centroids. In the next step, I want to associate a cluster number to each centroid. So I have two clusters, so I will use cluster number 1 for the first centroid and cluster number 2 for the second centroid. So I open this centroids.csv in Notepad++, so I can easily add this column here. So after user ID, for example, I will add a new column called cluster ID, and then after this user ID I will add 1 for all rows. So I search for it and replace it with, for example, 7119 and semicolon 1. So when I replace it all, you will see that after user ID there is a cluster number 1 for all rows belong to this user, and I have to do the same for this centroid. So I will go to search and find and change this user ID to 7120 and then go to replace 7120 semicolon 2. Now it replaced all the rows belong to the user 7120 with this extra number. If you open this in Excel, you will find an extra column here. So the new structure I use for Centroids is this one: user ID, cluster ID, movie ID, and rating. Okay, I run Talend Open Studio for data integration. If you want, you can use Talend Open Studio for big data, but since I don't want to put the file in the HDFS file system, I use data integration Talend. But it's up to you. If you want, you can use Talend Open Studio for big data. I want to create a new project, so I call this project as assignment 2. Okay, I create this and then finish. It takes a while to open the main page of the Talend Open Studio. My first step is adding these two CSV files to metadata. Okay, in the first step, I import those two CSV files here. So in the metadata section, I right click on file delimited and choose create file delimited, Centroids, for example. You can choose any name you want. Um, I put this name here in the purpose because it shouldn't be blank. And then browse for the Centroids file here. You see that the file viewer shows you the contents of the file. Go next. Tick this to show that your file has a heading row. And next. Okay. This is seen as a table, so I assume that user ID and movie ID, this combination would be considered as the key of this table. So the data type for user ID, cluster ID, and movie ID are integer. That's fine. But for rating, as you see, the rating is a floating number. So I change that to float and then finish. Now, again, I right click on this, create file limited, and this time I would import ratings here. Okay. Because the original rating file is too big and takes time for processing to save the time in this tutorial, I just selected 10 users and put this in a file named little ratings. So little ratings has the same structure and the same content, but just for 10 users, not 7,000 something users. Okay, so I click on this, see that the content is here. And next, the same for this one. And next, again, the combination of user ID and movie ID would be the key. Rating is float here, that's fine. Okay, finish. Now I create a job. I right click on job design and create a job. Call it, for example, clustering. Finish. Double click on this clustering job and drag these two files here. If it asks you about the component, just choose the default one, which is T file input delimited, and press OK. And this centroid. Okay, this is again T file input delimited. Now I want to find one by one the difference of ratings for each movie that rated by both the user and the centroids. So for each user and each centroid, I see which movies are rated commonly, and then I find the absolute value of the difference. To do this, I have to choose this component from here, TMap. TMap provides a mapping function, so I put it here, and I connect these two as the input of TMap. So right click on here, row, main, join it to TMap, and also for this one. You can rename these inputs. So if you double click on here, you can name it as ratings, for example, or whatever you like. If you're comfortable with this kind of naming, go ahead. And so for this one, for example, Centroids, that's it. Now I double click on this map. You see that these seem to be two separate tables. I want to join them based on these keys, so I have to connect this user ID to this user ID because they have to be the same. Sorry, this movie ID to movie ID, sorry, this is the foreign key for this table. So I drag it here to movie ID. Okay, and now these two tables are joined. The condition is movie ID for the user should be the same as movie ID for the Centroid. I click on this TMap setting here, and for the join model, I choose inner join instead. I'm quite sure that you know about the difference between inner join and outer join. Outer join may give you null values if there is no corresponding movie rated by the Centroid, but I don't want that. Okay, now I click on rating. I need an output here. Click on this. Then I call the output, for example, as difference of ratings. And click on this rating. Select all rows. Of course, I don't need rating. Just user ID, user ID and movie ID. So okay, so I select on click on this, select on the user ID and movie ID, copy and paste here. Okay, now from the second table I would like to copy cluster ID in the output, so I copy this again and paste it. Okay, and I can connect this to user ID here, so it seems that this output is the same as the user ID in the rating, and this output should be the same as movie ID in the rating. And this cluster ID is the same as this cluster ID in the Centroid. Okay, I need an extra column for the difference. So I click on here and name the new column as difference, for example. The type should be double because I want to use the mathematical function absolute value. If I click here on this button, I will find the list of all functions. I click on this all, for example, or mathematical functions, doesn't matter. The first one is the absolute function. So I want to find the absolute of ratings dot rating, the user rating, minus Centroids dot rating, Centroid rating. That's it. Okay, so you see that this is calculated from these two ratings columns from the input tables. All right, so we are finished with this one. Press OK. Everything is well. To check the result at this intermediate stage, I can find this tlog row component here. This tlog row shows you the output on the screen. Of course, later I will store the output in a file, but for the moment, to double check that everything is well, I use this component. So I right click on TMap and choose row and different of ratings to this one as the input. Then I double click on this, choose sync columns. Sync columns automatically copy the schema of the output of TMap to the input of tlog row. So the tlog row will show exactly the output of TMap, okay? And I would like to see the result as a table, okay? Now it's ready to run it. I will run it. Okay, this is the result. I expand this. Okay, as you see, the result is shown as a table: user ID, movie ID, cluster ID, difference. So it means that for the second movie, both user number 1 and Centroid number 2 have rated this movie, and the difference of the ratings is half. For movie number 32, both user 1 and Centroid 1 um, have rated this movie, and the difference is 1.5, etc. Okay, I would like to sort out this table based on, for example, user ID and movie ID. Yeah, it's sorted now. Um, okay, so I would like to sort this table based on user ID and cluster ID. Um, just for clarity, I don't think it is very necessary at this stage, but just to make it more clear. So I would use tsort row component, put it here, and I delete this output from here and give it as the output to tsort row, and the output of tsort row goes to tlog row. Okay, now when I run it, you will see that uh, the table is sorted based on okay, let me expand, make it bigger. So this is sorted. Oh, sorry, I forgot to uh, specify the criteria of sorting here. So I want to sort first based on user ID and then cluster ID. So I change this one as cluster ID numeric ascending. So first on user ID and then cluster ID. That's it. Okay, I run it again, and hopefully this time it will be sorted based on user ID and cluster ID. Okay, let's maximize this. Okay, now you see that for user number 1, I can see the difference with Centroid number 1. These are the differences. So I have to add them up to find the total distance of user 1 to cluster 1 to or Centroid number 1. And these are user 1 and Centroid number 2. This is the difference. So I have to add up all these differences to see what is the total distance between user number 1 and Centroid number 2. Whichever of these centroids closer to user number 1 would be considered as the cluster number of that user. Okay, now I will store the result in a file. So I would use t file output delimited, this one. So the result of this should go straight in this file. Okay, I double click on this and choose a path and name for this file. Okay, so for example, um, the default is out.csv. I rename it to difference of CSV. Okay, now I run it. After the execution of this, I will go and check the folder, and I expect to see a file named diff.csv. Okay, this is the file named diff.csv, as you see. This is the user ID. This is the movie ID, cluster ID, and difference. Okay. As you see, there was no heading row in the output file. If you want, you can double click on here and tick this option to include the header to the output file. Otherwise, you can do it manually. Of course, we don't need this header file always, but it would be helpful to have this header. But remember that if I try to run this, it would end up okay. So let me double check this time. Okay, here is the new file. As you see, we have a header here. So far, we know for each user and each centroid what are the differences among the ratings. Now I have to aggregate this information and sum up all differences for each centroid and each user, and for each user to see uh, his distance or her distance to to which centroid is shorter. That centroid would determine the cluster of that user. Okay, next step, I have to sum up these differences for each cluster and identify the distance of each user to each centroid. So I would add another aggregate component and connect this output to this T aggregate. Okay, in columns. So I group by user ID and cluster ID and sum up the differences. So on difference, I use the aggregation function sum, and the result will go, for example, in difference. Okay. Now let me use another tlog row to check the output. Okay, now running. Okay, now you see that here we have user ID, cluster ID, and the total distance. Okay, so I would see it as a table. Okay, so for each user ID and cluster ID, I will have the total difference. Okay, I can sort this to clearly see the result. Okay, so before this, I would add sort row, delete this, connect it to tsort, and tsort I would like to sort by user ID and cluster ID. And then this output goes to tlog row, run it. Okay, here it is. The the total distance of user 1 to centroid 1 is 5, user 1 to centroid 2 is 2.5, etc. In the next step, I would like to find the minimum distance here and assign that cluster to the user. So for example, for cluster 1, the minimum distance is 2.5, which belongs to the second cluster. So user 1 should belong to the second cluster. User 2 should belong to the first cluster because its distance to the first centroid is shorter than to the second centroid. Okay, so again, I put the result in another file, something like similar to this one. So I would use t file output delimited and connect this output to here. Click on this, include header, and the path should be the same folder. So this one I would choose total distance, for example. Okay, now I need this one for the next step to use this, so I would include that in the metadata. So file delimited, I create the file delimited, I would say total distance, and bring it here for the next step. Oh, I have to run it first, sorry, because yeah, total distance, that's fine. Let me run it to create this file, and then I can import it in metadata. Okay, this is the total distance file. You see that the total distance between each user and each centroid is given here. So next stage, I will find the minimum of this. Okay, I create a new job. So for example, I would call it clustered users. And I will drag this, oh, sorry, I need to include the previous file, which I call that total distance. Here. Okay. And this is the key. Okay, everything is all right. User ID and also, yep. Okay, now I drag this twice here. I will tell you why twice. I duplicate this. Okay, the first one goes to T aggregate row to find the minimum distance. Okay, so I sync columns, and then I will group this by user ID, and the function is minimum on the distance. Difference. So Now let me see the result. Oh, I have to choose this as a table, but doesn't matter really. Okay, so let's show it as a table and then run it again. Okay, as you see, for example, for user 1, the minimum distance is 2.5, and for user 2, the minimum distance is 2.0. But movie ID and cluster ID are null. That's why I need to have a second copy of that file, this total distance file. This second copy allows me to join the output of this with this one to find the cluster ID, because otherwise, how do I know each user belongs to which cluster? Okay, so I need to choose a T aggregate component again, T aggregate row. I aggregate this. Oh, sorry, it was my mistake. I need a TMap to join them. So I choose a TMap component, and join these two, and I will let you know what is the criteria of joining. Okay. Okay. Now this user ID should be equal to this one, and the difference is another column which I can join these two tables together, because this is the minimum distance, and this cluster ID here will give me the actual cluster ID which whose centroid has the minimum distance. Okay, now I create an output saying clusters, for example. And from this table, I copy user ID and cluster ID. Okay, and I add another column and I call it a square difference, which is the square of this. This is helpful for calculating SSE. If you remember, SSE is the sum of a square of differences, the total distances in one cluster. So this is the distance of one user. I multiply this by itself to find the square, and later I will sum it up. Okay, and don't forget to change this to inner join. Okay, now okay, and I connect this to another tlog row to check the output. Okay, Oh, there is an error here. This square difference, sorry, is it should be float, because this difference is also float, and I forgot to connect this user ID to this one and movie ID to this. Oh, so I don't need movie ID, sorry, I don't need movie ID, so I would delete this. I would like cluster ID instead. It's messy, sorry. So I would choose this cluster ID here, copy, paste it. So user ID from here, cluster ID from here. Okay, I hope this works now. Here it is. So user ID, the square root of difference is 6.225. Cluster ID is 2. So user 1 belongs to the second cluster. User 2 belongs to the first cluster. And you see that this is the square of total distance between each user and its associated centroid. Okay. Now, again, I explain this. So I join these two tables based on user ID from here and user ID from here, and also the difference. In the output, I have this user ID and cluster ID here, but the difference comes as a square of difference. If you want, you can move it at the end. Yep, that should be better. And I want to sort it out based on the clusters again to have a better view on this. So I delete this output and connect this to sort first, and the sort will consider cluster ID. So I want to sort it based on clusters. So again, we are nearly finished. The only thing we need to show is just SSE for each cluster, okay? So you see the first cluster includes only 2 users. The second cluster includes these users. Of course, it depends on the centroids, how many cluster users they would get, but doesn't matter for this. This is just a practice. And this is the square of total distances. So for cluster 1, SSE would be the summation of this, which is 5. And for cluster number 2, SSE is the sum of this, okay? Now, the only thing I need to use is another T aggregate row component. So I aggregate the output of this group by processing columns, group by cluster ID, not user ID, cluster ID. And we want to find the sum of total distances. The square of total distances. So this is sum total distances. This would be SSE for each cluster at the end. Okay. So I connect this again. Sync columns for that one. And hopefully this will give me the final result. Oh, fantastic. So you see for cluster number 1, SSE is 5. For cluster number 2, SSE is 160.25, which means that the users in cluster 1 are close to their centroids. But at the same time, you see that there are many users in the second cluster. So SSE alone is not a good metric to evaluate clusters, but it gives you an indication of the total distance among users. You can find the average of this per users if you want. For example, you can divide this at the end by the number of users in that cluster. But we don't want to do that at the moment. All right, that's it for today. Thanks for watching this video. I hope you can follow that and apply this k-means algorithm to the dataset and experiment with different cluster numbers. I just used here 2 clusters. You could use 3, 4 or more clusters, and instead of choosing the last 2 users as centroids, you can do it randomly. Thank you very much and bye.